We all just kind of assume we know what time is. It flows, it passes, we run out of it. But what if I told you that's all wrong? That time doesn't flow at all. And get this, the proof might just be sitting in your pocket. It all kicks off with this one single amazing fact. Your phone knows exactly where you are on the planet because two clocks, somewhere out there, disagree with each other. I mean, this isn't some abstract thought experiment. This is the tech that powers your life, right now. Okay, so you've got these GPS satellites way up there, about 20,000 kilometers up. Their clocks actually tick faster than ours down here on the surface. How much faster? To be precise, 38 microseconds faster, every single day. And I know what you're thinking. 38 microseconds? That's nothing. But oh man, does it add up. If engineers didn't program the satellites to constantly correct for that tiny difference, your GPS would be off by kilometers within a week. So this isn't just some physicist theory. This is real-world, nuts and bolts engineering.
Okay, so that leads us to the big puzzle, right? Why? Why do two perfectly identical, super precise atomic clocks tick at different rates just because one's a little higher up? Sure, the textbook answer is space-time curvature, thanks to Einstein, but that's just a label. It tells us that it happens, but it doesn't tell us how. What's the actual mechanism here?
To even begin to unpack that, we have to take a big step back and ask something really fundamental. Forget what you think you know and just ask, what does a clock actually measure?
We all have this picture in our heads of time as a river, just flowing along, right? But that's not what a clock is doing. Think about it. An atomic clock is counting the oscillations of an atom. A pendulum clock is counting swings. They're all just counting cycles. They're not measuring a river. They're sampling a wave. At its core, every clock is just a phase detector.
So wait a second. If every clock is just a wave counter, well, that leads to a pretty wild question. What if time itself is just a property of a wave? And this isn't some brand new idea. Way back in 1924, a physicist named Louis de Broglie suggested that all matter, at its heart, is a wave. This theory just takes that insight to its ultimate logical conclusion. Okay, to get how this works, let's use an analogy. Picture a recording studio. A guitarist plays a note. That sound wave fills the whole room, right? But you don't actually hear it or record it until it hits the thin membrane of the microphone. At that one specific boundary, the physical vibration turns into an electrical signal. It becomes information. So this theory says the universe is basically that recording studio. There's this fundamental wave filling all of space, but reality, our reality, only happens where we can measure it, at the boundary, the cosmic microphone membrane. The core claim here is that the boundary, that active measurement, that's what we experience as time. Yeah, that circle is time. Okay, hold on. A cosmic microphone? What on earth is this boundary made of? This is where the theory gets really interesting, digging into the actual geometry of reality.
All right, this is where it gets a little trippy, so stick with me. Forget your standard high school geometry. This model proposes our universe has this really unique shape, with a kind of twisted surface embedded inside it. Look, the complex math isn't the important part. What is important is this. The edge of this whole twisted thing forms one single continuous loop. And this theory says we live on that loop. That boundary is our reality, and every tick of our clock is just us taking one step forward along it.
And that leads to an idea that is, frankly, just mind-blowing. Think about how a CD works. It samples a piece of music 44,100 times per second to create a digital copy. Well, this theory proposes that the universe itself has a fundamental sample rate. Time isn't smooth and continuous. It's digital. It's pixelated. And that smallest possible tick, the tiniest possible sample of reality, has a name, the Chronon. It's like the atom of time. You can't get any smaller. It's the fundamental resolution of the universe.
So, okay, the universe has a sample rate. So what? What does that mean for you and me? It means that our entire conception of time as this smooth, flowing river is wrong. It doesn't flow. It clicks forward, one frame at a time, in these tiny, unbreakable steps. Because of this specific geometric shape we talked about, there's a fixed number of ticks per cycle of the universe's fundamental wave. And here's the crucial part. There is a minimum slice of time. Nothing can happen, no event can take place in a period shorter than one chronon. It's a hard limit, a fundamental law baked into the geometry of reality itself.
Okay, we're almost there. To finally crack that GPS puzzle, we need one last piece, and it's another simple analogy.
Think about a guitar string after you pluck it. It forms a standing wave. The middle part vibrates like crazy. That's a loud spot, high amplitude. But the ends, where it's attached, don't move at all. Those are quiet spots. The wave is there along the whole string, but its intensity is different depending on where you are.
And that is the absolute key. What if the universe is just like that guitar string, a giant standing wave with loud spots and quiet spots? Now we can pull all these threads together and finally solve for time.
Here's how it all comes together to explain time dilation. It's not one thing, it's two. First, gravity. Being higher up, like that GPS satellite, is like moving to a louder spot on the cosmic guitar string. The wave's amplitude is higher there, so your clock samples it faster. It ticks quicker. Second, velocity. Moving really fast from our point of view actually contracts the length of that temporal edge you're on. A shorter edge means fewer ticks can fit into our measurement. Your clock appears to tick slower.
And just like that, the puzzles are solved. The GPS satellite's clock ticks faster because it's in a louder spot in the gravitational field. The famous muon experiment, where short-lived particles reach the Earth from the atmosphere, their incredible speed contracts their temporal edge from our perspective. We see their clocks ticking slower, giving them enough time to make the journey. It's all one beautiful, consistent mechanism.
So where does that leave us? We've gone through GPS, cosmic waves, crazy geometry, and it all points to a complete reimagining of what time even is. It's not about when, it's about where.
Okay, let's wrap this up. Here's the bottom line. First things first, time does not flow.
It ticks in these tiny, unbreakable bits called chronons, frame by frame.
And how fast it ticks? Well, that's not the same for everyone. It all depends on your position and your motion inside that giant cosmic wave. So you see, time isn't what's passing, it's where you are. Forget the river. Time is just another coordinate, another part of your address in the universe, just like up, down, left, or right. And if that's really how it works, well, that changes absolutely everything, doesn't it?